Kia ora koutou. In this video, I'm going through the last part of paper 53 from November 2021. So this is Stats 1 for people doing AS. In the first question, question 6, we've got 4 parts and they're all about Jim throwing 3 darts at a board. The probability distribution for the number of darts in a turn, which has 3 throws, of how many hit the bullseye is given here. So this means that none of the 3 hit the bullseye. The probabilities are given here, and you can see that we're missing 2 of them. We're also told that the mean of the distribution is 0.55. So the first thing we have to do is find the values of P and Q. So we need 2 bits of information to find 2 unknowns. The first bit of information is obvious, it's this one here, but the other one is really easy if you remember that you've got a probability distribution. So these numbers have to add up to 1. So the first thing we can write down is that 0.6 plus P plus Q plus 0.505 is equal to 1. That gives me P plus Q is equal to 0.35. Next, we have to apply the definition for the expected value. And we do that by weighting the probabilities, weighting the outcomes, 0, 1, 2, or 3, by the probabilities. So the formula for that is just this. So here we've got 0 times 0.6 plus 1p plus 2q plus 3 times 0.05, and we know that that equals 0.55. Right, so working that through gives me p plus 2q is equal to 0.55 minus 0.15, which is 0.4. So we can solve those very easily because we know that P plus Q is 0.35. That means that P plus Q is equal to 0.4. Substituting in the 0.35 gives us Q is equal to 0.05. And that means that P must equal 0.3. Okay, so that's the first part of the question done. And from there we can go on and we can find the variance of x for the second part. Now, whenever we're finding a variance for a discrete random variable, we're going to need to be working with the x squareds. So when I've got a probability distribution table, I like to put in a row just up here with the x squared values straight away. So we've got 0, 1, 4, and 9. The variance of x is given by this. Instead of weighting the x values like we did for the e of x, we're going to weight the x squared values. So it's going to be the sum of the x squareds times each probability minus the mean value squared. Right, so we're working out this measure of how spread out the distribution is. And we know now what P and Q are, so we can write those into my table. So P worked out to be 0.3 and Q worked out to be 0.05. That means that in here, the variance will be 0 plus 1 times 0.3 plus 4 times 0.05 plus 9 times 0.05. Now it's really easy to stop there and forget that we have to subtract off the mean squared. So it's minus 0.55 squared. And when you put all of that into your calculator, you get 0.95 for the first bit minus 0.3025 for the second bit, which gives me a value of the variance of 0.6475. Now, I'm sorry for writing it all squished up like that. The reason I did that is that I wanted to have access to that table on the screen so I could show you the step of putting the x squared line in here, because I think it really helps you not to muck it up. So that's the second question done. Okay, so this next question changes things a little bit. The first 2 questions were about what happens on a turn, right? And a turn is having 3 shots at the dartboard. In here, in the next part, in part C, Jim is practicing for competition, and so he's going to do this over and over again. And in this question, we've got a binomial distribution because we have to find the probability that in at least 3 of 12 randomly chosen turns, he gets x equals 1. And remember, the probability of that happening is 0.3. So what can I say about that before we start? Well, one thing that's good to do is to realize that we're working with a new random variable, which is the number of times that he gets 1. So y, it's good to call it a different name. What have we got? Well, y is a binomial distribution. It's got a fixed number of trials of 12, and it's got a probability of success of 0.3. And our job is to find the probability that he gets at least 3 out of 12 goes where he's getting a 1. The easiest way to work this out is to find the 1 minus the probability of 0, 1, or 2 goes being successful. So that's 1 minus, so the first one, we can do this with our coefficients, right? So this is 12 choose 0 times 0.7 to the power of 12 times 0.3 to the power of 0 plus 12 choose 1. 11 fails and 1 success. And now we have 12 choose 2 times 0.7 failures and 2 successes. Now, in actual fact, most of you watching this will realize that this number here is just 1, right? And this is just 1 as well. So you don't have to write that whole term out. But it's good practice when you're getting up to here, you do have to write it out. And you want to be able to show the person reading this that you really understand the binomial distribution. So we can go from here, and this gives me 1 minus each of these. That gives me a final answer of 0.747. I'm just going to show you what would be perfectly acceptable reduced working for this question. I'm just going to put a couple of things in. So in here, it would just be this, to put 0.7 to the power of 12 for that first term. And then in here, we have to add in the 12 times. Right, but if you're thinking about your 12th row of Pascal's triangle, you know that the coefficients are going to go 1, 12, blah, 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 and then at the end they're going to go 12 and 1, right? So make sure that you've shown at least one term where you're showing a good understanding of the binomial distribution, but it's fine just to do those ones like that. Okay, the last question, question D, is just 1 mark. And it's a nice little easy geometric distribution question. But you really don't even have to think about a distribution. Just think about a big tree. Find the probability that he first succeeds in hitting the bullseye with all 3 darts on his 9th turn. So what we've got there is just visualize a tree diagram where he's got something other than 3 on the first 8. And then on the 9th, he gets all 3. So it's like this in your head, right? So this going out 8 times, 1, 2, 3, 4, 5, 6, 7, 8, and then success on that one. So the probability, all 3 on 9th for first time or something like that, will be equal to 0.95 to the power of 8 times 0.05, right? So I'm just pulling those numbers out of the table. And what does that equal? I actually can't remember what that equals. So go and chuck that in your calculator, and whatever that number is how you get the 1 mark. Right, now on to part 7. So in question 7, completely different setup, but a pretty straightforward tree question as long as you've read the wording really carefully. The first part of question 7 is just requiring us to fill out the tree diagram. And then the second part and the third part uses information from that tree. Okay, so we've got 2 boxes, and box A has got 6 red balls and 4 blue ones, and then box B has got some number of red ones and 9 blue ones. And we take a ball out of box A and we put it into box B, and then we choose from box B. So you have to understand that setup so that you can get your box B probabilities. So if we think about what's happened here, this is where we choose a red ball from box A. Box B has got X. Let's just put box B so we don't confuse it with the colours. It's got X red, and then it's got 9 blue. Now, if the ball that came out of A was red, that means that it's going to have X plus 1 red balls and 9 blue ones. So the red probability here will be x plus 1 divided by x plus 10 for the total number. And here, if the red ball was chosen, then we're going to have 9 blue possibles out of x plus 10. But if we chose a blue ball from box A, then in box B, we're going to have how many? Well, box B has got x red balls. It's still going to have x red balls, but it's going to have 10 blue ones. So the total in either case, of course, will be x plus 10. The probability here that we choose a red ball from box B when we transferred a blue one will just be x over x plus 10. And the probability that we get a blue one will be 10 over x plus 10. So if you've gone carefully through that setup, I think those 3 marks are not too bad, and I think the rest of the question is not too bad. Part B for 2 marks is to show that the probability that both balls chosen are blue is 4 over x plus 10. So all we have to do is multiply down the probabilities. So it's going to be 4/10 times 10 over x plus 10. And the 10s simplify away, giving me 4 over x plus 10 as required. Next, we're given that we're shown, what are we told? We're given that the probability that both balls chosen are blue is equal to 1/6. So that lets me figure out what x is, right? So the probability of getting BB is equal to 1/6, and we know that BB is given here as 4 over x plus 10. So even if you'd mucked up the rest of this question, you could use this fact to answer this problem. That gives me x plus 10 is equal to 24, so x is equal to 14. And now we can go on and figure out the probability that the ball chosen from box A is red. Given that we chose a red one from box B, we have to figure out that probability. So we're going to use our conditional probability idea. Given that B happens, what are the chances that A happens? So that's equal to the probability of both of those things happening, scaled or divided by the probability that B happened to start with. So in here, what we want is we're trying to find this probability, the probability that A is red, given that B is red. So in the numerator, we've got to find the probability that A and B are both red, and in the denominator, we're just finding the probability that B is red. The probability that A and B are both red is going to come from here. Red and red. So it's going to be this times this. Let's get rid of some of the other stuff on here. Maybe not. Okay. So the numerator in here will be as follows. So it's going to be 6/10 times x plus 1 over 10 plus x. And the probability that B is red is going to have 2 bits. It's going to have red, red, and then blue, red. So 6/10 times x plus 1 over 10 plus x plus 4/10 times x over 10 plus x. And you can see that in here, we've got a common denominator here, here, and here. So this fraction simplifies nicely, and we can put in what x is at any stage, to 6 times, well, x is 14, so it's going to be 6 over 15 times 6 times 15 plus 4 times 14. And that gives me 90 over 146. Or simplifying my fraction, 45 over 73. And if I take that through to a decimal and round it as requested, we end up with 0.616 to 3 sig fig. So there you go. Thanks for watching. Based on the views, I'm going to keep on doing these, but I'm going to do a little bit of A-level stats next. So just fire in any questions as you've got them.